We spent last video introducing the concept of a vector-valued function, just a vector function. Let's think about what it means to graph a vector function. And so this is a classic example here. R of t is cosine t I hat plus sine of t j hat plus t k hat. Let's graph this. Let's figure out how we can graph this. Let's put a little restriction here that we'll graph this for non-negative values of t. So first off, I want to look at the I hat and j hat components. So if we restrict ourselves to thinking about what's going on in the I hat, in the xy plane, cosine t, x is cosine t, y is sine of t. That should feel familiar from our study of parametric curves and stuff like that in Calc 2. This is a parameterization. We just look at just this right here. This is a parameterization of a circle. And so we're just going to, if we just look at these two things, we're looping around in a circle in the xy plane. So that's what this would be if the k hat component here were 0. But the k hat component here is not 0. The k hat component here is t. And so what happens is that as t is increasing, the k hat component is going to get bigger and bigger and bigger. So instead of drawing, let me draw, I just drew, 2 dimensions here. It's time for me to draw 3 dimensions. So here's x, here's y, here's z. So once again, if we were ignoring this, we would just be going around kind of putting this little dotted circle here because this isn't the real thing. We'd be going around this dotted circle in the xy plane. But let's see, when t is 0, we do start off right here at the point 1, 0, 0. But what happens is that as t gets bigger, we're going to move up along the z-axis. So we're going to move something like this. And so what kind of shape is this? This is a helix. You might also think of this as, the slinky toy. The previous textbook we used to use in this class a couple years ago before we switched to Thomas, famously always had a slinky on the cover of it for this kind of reasons, that you start here and you spiral up, going up in this way. Yeah, so this is a classic vector value function. This all of this, if we were to draw a cylinder here, if we would draw a cylinder moving up and down, this helix, all of it would lie in that cylinder. There's lots and lots of other things that you can graph. A lot of these are difficult to graph by hand. I'd recommend, this is a rather short video, I recommend taking a look at some examples from the textbook at this point.